Consider a scenario. Natasha wants to participate in the 200-meter sprint. She can currently run that distance in 45 seconds, but she wants to do that in under 30 seconds. With each day of practice, it takes her 2 seconds less. Find out the minimum number of days she needs to practice in order to achieve her goals. So, the highlighted information in this is that she can currently run that distance in 45 seconds, but she wants to do that in under 30 seconds. With each day of practice, it takes her 2 seconds less. You can see that she does this now in 45 seconds, and now with each day's practice, she is going on doing it with 2 seconds less. So, the next day she will do it in 43 seconds, then the next day she will do it in 41 seconds, and so on. So, you can see that her practice timings are actually making a series where the difference between two consecutive terms is constant, or you can say it is common. Here it is 2 seconds less. Such a series is called arithmetic progression, or AP in short. Let's discuss this series arithmetic progression in detail. What actually is an arithmetic progression? How to identify an AP series? What are the minimum informations that we require to know about an AP? All these things we will be discussing here. Now, consider the following list of numbers: 1, 2, 4, 6, 8. Second list: 100, 80, 60, 40. Third list: -5, -3, -1, 1, 3, so on. Each of the numbers in the list is called a term. Given a list, can you write the next term in each of the list? If so, how will you write it? Now take the list 2, 4, 6, 8. We can find that each term is 2 more than the preceding term. 2 is the first term. Adding 2 to 2, we get 4, right? Now, adding 2 to 4, we get 6. Adding 2 to 6, we get 8. Now, take the next list: 100, 80, 60, 40, so on. We can find that each term is 20 less than the preceding term. 100 is the first term. Next term 80, which is 20 less than 100. Again 60, which is 20 less than 80. So, from all this example which we have discussed here, we can infer that in an AP, the successive terms are obtained by adding a fixed number to the preceding terms. So, we can define arithmetic progression as it is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. And this fixed number is called the common difference of the AP. So, we can write succeeding term is equal to preceding term plus common difference. We will discuss more in detail about this common difference. Let us denote the first term of an AP by A1, second term by A2 and the nth term by An. Then the common difference is denoted by small letter d. Then the AP becomes A1, A2, A3 up to An. Then the common difference is obtained by subtracting any term from a succeeding term. That is, d is equal to succeeding term minus preceding term. Also, the value of d should be same for an AP. That is, A2 minus A1 will be equal to A3 minus A2, which will be equal to An minus An minus 1. In general, for an AP, A1, A2, A3 up to An, we have a common difference, and the general equation is d is equal to ak plus 1 minus ak, where ak plus 1 and ak are the k plus 1th and kth terms respectively. So, to obtain D in a given AP, we need not find all of A2 minus A1, A3 minus A2. It is enough to find only one of them. Now, what about its value? Is it always a positive value? The answer is no. Common difference can be positive, negative or 0. Let's see some examples for more understanding. For the list of numbers 1, 4, 7, 10, 13. What is the D? D is equal to 4 minus 1 is equal to 3. Therefore, the value of D is positive. Now, consider the list of numbers 7, 6, 5, 4, 3. What is the value of D? D is equal to 6 minus 7, which is equal to minus 1. And we have seen the value of D is negative. Now check list of numbers 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. What is D? D here can be calculated as 1 by 2 minus 3 by 2, which is equal to minus 2 by 2, that is minus 1. Here also the value of D, we got it as negative. Again, for the list of numbers minus 5, minus 5, minus 5, minus 5 and so on. What is the value of D? Minus 5 minus of minus 1, which is 0. Therefore, the value of D, we got it as 0. Thus, we can say common difference can be positive, negative or 0. Next, we will discuss the general form of an AP. The general form of an AP can be written in terms of first term and common difference as A plus D, A plus 2D, A plus 3D and so on, where A is the first term, D is the common difference. To know about an AP, what is the minimum information that you need? Is it enough to know the first term alone, or is it enough to know only the common difference? You will find that you will need to know both the parameters, the first term as well as the common difference. With this, we can form the AP as A plus D, A plus 2D, A plus 3D and so on. Similarly, if you are given an AP, you can find its first term and common difference. For example, determine arithmetic progression whose first term is 5 and common difference is 2. Let's see the solution. Put the values in the general form of AP. A plus D, A plus 2D, A plus 3D. What you will get? We get the first term is equal to A is equal to 5. Second term is equal to A plus D, which is equal to 5 plus 2 is equal to 7. Third term A plus 2D, which is equal to 5 plus 2 into 2, which is equal to 9. Fourth term, what do you get? A plus 3D. Substituting the value, we get 5 plus 3 into 2, which is 11. So, what is the AP we get? Which is 5, 7, 9, 11 and so on. Also, given a list, we can tell if it is AP or not. How we can check? By checking its common difference. If it is the same, then the list forms an AP. Consider the list 2, 4, 6, 8, 10. Here, 4 minus 2 is equal to 6 minus 4 is equal to 8 minus 6 is equal to 10 minus 8 is equal to 2. Thus, it is an AP with the common difference 2. Right? Consider another list 1, 3, 4, 6, 7. Here, if you take D, 3 minus 1 is not equal to 4 minus 3. Thus, it is not an AP. There is no common difference. Right? Now, next we will discuss finite AP and infinite AP. What is finite AP? It is an arithmetic progression with a finite number of terms. It has a last term, right? For example, 1, 3, 5, 7. Now, what is an infinite AP? Just the opposite. It is an arithmetic progression with an infinite number of terms. It does not have a last term. For example, 1, 3, 5, 7, 9, so on, etc. So, let's have a recap of what we have discussed in this section. Through an example, we have seen what an arithmetic progression is and its basic concepts. We define arithmetic progression as a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term, and the fixed term D is called the common difference. We also discuss more about common difference. Common difference is obtained by subtracting any term from a succeeding term. That is, D is equal to succeeding term minus preceding term. That is, we have also seen the equation D is equal to AK plus 1 minus AK, and the value of D can be positive, negative or 0. Also, we should remember the value of D should be the same for an AP. A given list of numbers A1, A2, A3 is an AP only if the differences A2 minus A1, A3 minus A2, A4 minus A3 give the same value. Also, the general form of an AP is A plus D, A plus 2D, A plus 3D and so on. Also, we have discussed the types of arithmetic progression, finite and infinite arithmetic progression. Finite arithmetic progression is the one with a finite number of terms and also has a last term. Infinite AP is an AP with an infinite number of terms, that means it does not have any last term.